Welcome in lecture series of electrical installation and practices. Now our topic is starters. So we know that we have to use different type of starter for different type of motors, and it is necessary in for reducing the inrush current or starting current, because every type of motor takes high value of starting current. To avoid the damage of distribution network or to avoid the damage of motor itself, it is necessary to use starters. So a starter is a sort of protection device which is used for the motor to for inrush value of current. Now we will see the different type of starter: DC motor starter, DOL starter for three-phase induction motor, star delta starter for three-phase induction motor, auto transformer starter. Now there are different type of contactors and relay as a component of starter, and last is the power factor correction in this lecture series and part of the lecture series. Now first we will start from the DC motor and DOL starter. Say this is the DOL DC motor starter. We know that the starting speed EMF induced back EMF in the case of three-phase, in case of DC motor, back EMF is equal to phi is the flux per pole, Z the total number of conductor, N is the speed, P is the number of pole upon 60A. 60 is the numerical value and A is the number of parallel path. At start means as soon as we switch on the motor, speed is equal to 0. So back EMF again at the time of starting is 0. Now the armature current for example DC shunt motor, armature current IA is equal to V minus back EMF divided by armature resistance. So the armature resistance is very small in the range of 0.5 ohm, and supply voltage, say DC voltage is 230. So if you certainly apply the 230 volt minus back EMF at the time of starting is 0 divided by 0.5 is the resistance. So armature current at the time of starting, we can say that it is equal to 230 divided by 0.5, it is 460 ampere. So this inrush value of 460 ampere definitely damage the motor as well as the distribution wiring connected to the motor. To avoid the high value of starting current and the damage of our motor, we will insert some resistance in series with the armature. So now let this resistance is added in series with the armature. This is the armature of motor, and let the resistance is R, whose values is, for example, say 50 ohm at the time of starting. When the arm is placed at the starting position, so now armature current at the time of starting is equal to 230 volt is the supply voltage, minus 0 is the back EMF is 0 at the time of starting, and 0.5 plus 50 ohm. So now the current become at the time of starting is hardly 5 ampere. So now this is 5 ampere is a safe value, and once the motor pick up the speed, the back EMF start developing, and we are gradually reducing the external resistance connected in series with the armature. So now at running condition, armature current is equal to supply voltage minus back EMF divided by the resistance of armature circuit. So that's why we are putting some resistance in series with the armature to protect the motor from inrush value of current. So this is the 3-point starter. It is why it is called, because one point is connected to the line, second point is connected to the field winding, and third point is connected to the armature winding. Let's start from the positive terminal of supply. Say this terminal is connected with the overload coil. Second, it is goes to the arm, and this is off position. means one is the off position. Armature does not receive any type of voltage. So it is the off condition. As soon as we move the arm to the position 1, this resistance R1, section of the resistance R1, R2, R3, R4 and R5 is connected in series with the armature. And whereas the field is directly connected with the supply. So now the motor get started. Once the motor is pick up the speed, we will gradually move the handle from position 1 to 2. So that resistance R1 is disconnected or this cut out. So now the speed of the motor get increases. Now we will move to the handle to position 2, 3, 4 and till its run position. So when the handle come to the run position means all external resistance is cut out from the series of armature circuit. So this is the starting position. Entire resistance is connected in series with the armature. When we'll move the handle to this position here, entire resistance is cut out and only we are getting the rated voltage across the armature. So in this way, we can reduce the starting current of the DC motor. Now, in addition to reduce the starting current, we will provide some sort of protection in the starter. So first is the overload coil. Overload coil is connected in series with the entire motor. So now if the motor current is more than the rated value, say for example, the rated value is 20 ampere and if the current is 25 ampere, this plunger pick up this soft iron. This soft iron is now make the short circuit at point B and A. Now see, this point B and A is connected across the holding coil. This holding coil is a soft iron electromagnet which will hold the handle in the on position or run position under normal working condition. So once point A and B is shorted, say this is shorted, the current does not flow through the holding coil and it will release the magnetism or it will release the handle against spring tension and the motor now trip out or motor get off. So this is one type of overcurrent protection provided to the motor. Second is that if suppose the voltage is less than the required voltage, say rated voltage is 230 volt and if the voltage is 190 volt, this 190 volt does not hold the handle in on position. So again, it will come to the off position. Or you can say that if suddenly the supply cut out, the motor get switched off against the spring tension because the holding coil magnetism becomes zero and it will provide the under voltage as well as the overcurrent protection for the DC shunt motor. So this is the starter of DC shunt motor. So it is called as a starting resistance because it is connected in the starting position. It is the soft iron which is used to hold the handle in off on position or run position. Now start handle, this is the handle, it is an isolated handle and in between there is a wire are provided for making the contact position at 1, 2, 3 and so. This is the spring, so against the spring tension, the motor will remain in off position. This is the overload release coil or an over voltage overcurrent protection is provided. This is the say kind of DC motor starter. So next is the AC starter, AC motor starter. Generally, it is a one is called as a DOL starter. It is nothing but the direct online. Direct online. Online means it is not a like a online or this one. It is a means we are not providing any sort of reducing the voltage at the time of starting. So in case of three-phase induction motor, suppose the motor is connected in delta. Motor is connected, the stator winding is connected in delta. This is the delta connected motor, three-phase induction motor. And now we are applying the rated voltage VL between these two terminal. The impedance of this phase is Z1, this is Z2 and Z3. So starting current at the time of starting, again the speed is 0. It acts as a short circuit secondary of transformer because three-phase induction motor is a generalized three-phase transformer where the secondary winding is nothing but the rotor winding. For squirrel cage motor, it is a self short circuited bars are provided in the form of squirrel cage. So secondary winding is short circuited, and it at the time of start it is stationary. So it act as a short circuited secondary of the transformer. As soon as we supply the rated voltage, the starting current is equal to V rated, means line voltage divided by the impedance. So definitely the starting current is very high as compared to the full load current of motor under normal working condition. It is generally the starting current is equal to 5 to 7 times full load current. So full load current. It means that if suppose the motor full load current is 10 ampere, so at the time of starting, induction motor draws around 50 to 70 ampere. Again, this 50 to 70 ampere is may damage the wiring, may damage the stator of the winding of the three-phase induction motor, and it will give the dip in the voltage, the other line which is connected to the motor. So that's why we are using the starter. But the DOL starter is used only for up to the 5 HP motor. If the motor capacity is more than 5 HP, we have to use different type of starter where the starting current can be stepped down for a safe value at the time of starting. But for the 5 HP motor, the starting current is, the full load current is 7.5 ampere or 7 ampere is there, and the starting current is only 50 ampere. That will be the manageable. And say we are going to use such a wiring and such a backup fuses are there in such a way that the motor does not get tripped. The motor will not trip under the starting current. So in case of starter, what are the different components are there? This is the three-phase induction motor, and the supply terminals is RYB. We are using the fuse as a backup protection. This may be the rewirable fuse. Generally, we are using the HRC fuses, and nowadays we are using MCB of the different class where the starting current is more, so therefore we are not using the B class B class MCB, whereas we are using a different class of MCBs for the MCBs for the induction motor, and we should use different class of MCBs for the lighting purpose, or different purposes are there. So this is the contactor. The contactor has 4 terminal, 3 terminal as a power contactor, and 1 is the auxiliary contactor. So this contactor is an auxiliary, whereas it is connected to the line of motor or phases of the motor. So it is a phase contactor 1, 2, 3, and 4th is the auxiliary contactor. This is the overload protection. It is a bimetallic strip. When the current more than the rated value of the motor, the overload strips get bent and it will trip the motor. So it is a overcurrent protection we are going to provide here. This is this black wire is a control circuit. So this is power circuit. This circuit will be called as a power circuit, and whereas this circuit is a control circuit. Control circuit. The circuit is used for controlling on and off of the motor. Protection we are going to provide in this circuit itself. Therefore, it is called as a power circuit, control circuit. Now, how the control circuits are there? Say this control circuit is connected between 2 phases, then it will be a neutral. It will not be neutral. It is a phase 1 and phase 2. If control circuit is connected between one phase, any one phase, and the neutral, then it will be like that. So this is the line current. We are providing one small MCB, say it may be a 6 ampere because it is a control circuit only. First is the overload. This is overload protection, means overload coil, overload elements are there. It is a normally close. This is normally close, and then it is a off. This is off switch button. So again, it is a normally close, whereas it is a start button. So this is a start button. It is normally open, means as soon as we push on the button, the contactor will make the current is going to flow, and as soon as we release the hand, it will again become an open one. So it is a normal open. In parallel, we are connecting a holding coil. So this contactor, this contact is the holding coil K. So this is K1 is here. This is K1 is here. So holding contacts are there. That is normally open. And now there is a contactor coil. So this is the coil. This is the electromagnet coil, which will attract the plunger in this direction. So as soon as it will get the supply, it will attract the plunger. So once the plunger get attract, this make the coil, this make the contact is here. This will make the contact. This will make the contact because your contact is going to move in the left position. And one more, it is an auxiliary contactor. Once the auxiliary contactor get switched on, the coil getting the supply from this one terminal MCB to overload contact, from the normally off condition, your off push button is there, then from the auxiliary contact and auxiliary contact to the holding coil. So the motor will get started. Now, if suppose we want to stop the motor by manual operation, so as soon as we push the button here, so it is a normally closed. Now it become open. So as soon as it become open, the holding coil supply get trip. Means the holding does not receive any current, and when it does not receive the current, it will release the plunger against spring tension. So it is connected with the spring. So as soon as this coil is de-energized, it will release the contact, and once it is released the contact, the motor get switched off. This is the one position. Second is that because of some overcurrent or because of some overloading condition to the motor, it will draw more current, and because of more current, this bimetallic strip get bent and it will trip the contact. So when it will bimetallic strip get bent, because of the temperature rise, it will again open the contact. So again, the contactor does not receive the current. So here again, the contactor get de-energized and it will release the contact against spring tension. So by any way, either by overload or either by manual switch off, we can switch off the motor, or there is a tripping of the motor is there, isn't it? Next, if suppose we want some extra auto switch on, so we can add the switch button, start switch button, or some really some sensors are there. With the help of sensor, we can make the contact on. So on all on buttons, all on positions buttons are connected in parallel, and whatever the element which or whatever the sensor which is used for the stopping the motor or switching off the motor, those are connected in series. Say for example, for the compressor, if you want to switch off the motor as soon as the compressor say compressed air or say pressure become sufficient, so it is connected, the pressure is connected, the here means the pressure sensor is connected with the help of one more contact in the one more say switch in series with the stop button. And if you want to make the motor on, automatic on, it is connected in the parallel. So all on buttons, all on sensors are connected in parallel with the start button, and all sensors which is used to trip the motor or switch off the motors are connected in series with the stop button. So this is called as a key diagram. Key diagram is very important to understand the starters operations, their automation systems, remote automation, remote control of the motor, remote control with the wiring system. So this type of contactors are used, this type of control circuit are used, and this is called as a DOL starters. Next is this is the say real picture of the DOL starter. This is the phase terminal. It is connected as a main MCB, that is called as a backup protection. Whenever some fail, so it is going to protect or by the short circuit. So it is a MCB here. See, just here we are using this fuses or MCBs are there. So this is the one MCB. Now this is the power circuit. RYB is a power circuit, goes to the contactor 1 is a L1, L2, L3. Second contactor terminal comes here. So this is connected to the overload coil. So which is contactor? This contactor is nothing but this is the contactor. So this is the contactor is here. Second is the overload coil. So this is the overload coil. This is your overload coil. And here there are settings are there, 1.2 times and so on. So as per this rating, suppose the current is 10 ampere to say 15 ampere. So here we can set either 10 ampere, 14 ampere, 13 ampere and so on. And these are the terminals are connected to the three-phase induction motor. Now this is run means push on button, start button. This is stop button. And whenever we want some other, this is the indicators are there. The motor is on, the motor is off, and motor get trip. So whenever there is something happen wrong, the motor get trip out and it will indicate. So we can provide some indicators also for the starters. So now see what are the different component, actual component. This is the contactor. Under on condition, this contactor will backside means it is get pushed inside. So the contactor is on. This is 1, 2, 3 is the phase terminals, phase contacts are there, and one is the auxiliary contact as explained. Now this is the starter relay is there. This is the bimetallic starters are there. It is connected from one phase, second phase, third phase, and this is outgoing terminals are there. And here this is the dial where we can put a setting of the current of the motor. Say the relay is from 10 to 15 ampere. So if our motor full load current is 12 ampere, we can put to the 12 ampere. If the full load current is say 15 ampere, we can put to the 14 ampere as a protection point of view. This is the starter, dual starters are there. It is contactors. This is gravity type contactors are there. And this is the fixed contact. This is movable contact. As soon as we energize the starter, this movable contacts get upside because of this electromagnetic relay. It will make the contact 1, 2, 3, and one is the auxiliary contact. This is the dial where we can set our current, rated current. So this is different type of contactors are used here for the small capacity 2 HP, 3 HP motors. It may be a say 5 HP motors. So in case of a different starters, we are using a different type of contactors and relays are there. So this is the star delta starter. In case of the star delta starter, what happened? The starting current is equal to the V load line voltage divided by the impedance of per phase. This is the starting current. Now, if the motor is connected, in star, what will be the change? So when the motor is connected to the star, what happened? This is the line voltage, whereas this voltage is the phase voltage, which is equal to V line divided by √3. So when the motor is connected in star, so starting current is equal to V line divided by √3 divided by ZS. Is the ZS or Z1 or Z1 is there. So it is the impedance per phase of the three-phase induction motor. The meaning is that the starting current can be reduced as compared to the DOL starter by 1 upon √3. So it is the decrease in starting current. So that decrease in starting current for more than 10 HP motor can be obtained by the star delta starter. So star delta starter is more common everywhere. Here the motor is get started in case of star condition. So see here, this is A1, A1, B1, C1 is the supply terminal, and C2, B2, and A2 is there are 3 windings are there. This is 1, this is 1, this is 2, and third winding for the 3-phase motor. So let it is A1 terminal, it is A2, B1, B2, and C1, C2. So if we are supplying the power to the A1, B1, and C1, and these three terminals are connected to each other. Now it becomes a star winding. So here B2, C2 and A2 is connected with the star one, means all these are short circuited in the first position. So motor get started in star. Once the motor pick up the speed, it is quickly changed to this terminal 1, 2, 3, this terminal. So what happened? The motor is connected. So this is the three terminals, three windings are there, and three winding having 6 terminals in the terminal box. So it is connected with the supply. This is 1, 2, 3, whereas A1, A2, B1, B2 and C1, C2. Now we will connect it to the A1 is connected to B2, C1 is connected to C2 and C1 is connected to the 2. So now it become a delta. So there should be a arrangement in such a way that the motor get started in star. Once the motor pick up the speed, the starting current will be higher, but it is gone decreasing with respect to the increase in speed. Once the motor current is small, when the motors pick up the speed, we will change into the delta. So this is called as a star delta starter. Motor get started in star and motor now change after some few seconds, it is get converted into the delta. So definitely there should be a three contactors. One is the main contactor, second is the delta, and third is the star. So at the time of starting, this contactor is first, it is going to operate, so it will make the motor in star. So all three terminals are short circuited simply, so it is motor get started in star. After some time, this delta is going to close and it is going to open. So now the motor is connected in delta. So this is called as a star delta starter. So again, we are using MCB as a backup fuse or backup protection. It is a main contactor. This is overload coils. We are providing overload current protection in case of induction motor as earlier. So see, this is the wiring diagram. These are the three terminals are the power lines. So it is a power circuit, whereas this is the control circuit. This is one contactor is a first contactor is a main contactor. This is a star contactor and this is delta contactor. So in first position, in the first instant, this main contactor and star contactor going to operate. After some time, this is going to open and delta is going to close. So it will make the motor say in delta. So this is the key diagram. Similar key diagrams are there, and these are the contactor 1, 2, 3 contactors are there, and it is going to operate in the same way. And again, we can use some remote start and remote off condition. In the same way, all the off buttons are connected in series with the stop button, and all start button are connected, or all start sensors are connected in parallel with the start button. So this is the schematic diagram. We are using, this is a 3-phase MCCB because it is a motor, higher capacity motor. This is the 3 contactor. This is main contactor. This is delta contactor, and this is a star contactor, and this is motor. So how many terminals are there? There are 6 terminals for star delta starter, and for the motor higher than the 10 HP motor, terminal box having 6 terminal, 3 for to make the motor start, star and delta. So this is the overload relay coil. It is similar in the previous case. It is a start button, stop button is there. So all the red color and the blue color is nothing but the control circuit. It will give the indication on, off, trip, and whereas this 3 terminal 1, 2, 3 is the power circuit, and MCB is used as a control circuit. So MCB also using for the control purposes. Now we'll see the picture of 3-phase star delta starter. So it is somewhat clear. This is delta starter, main starter. This is the star starter, and it is delta starter, and we are using some clock circuit or some say timer is there. So it is a timer. So in case of automatic star delta starter, as soon as we switch on the button, start button, the motor get started in star, and after 30 second or 15 second, the motor get converted into the delta. So it is called as a star delta starter. Automatic star delta starters can be used for three-phase induction motor. And whereas in the terminal box, there are 3 terminals. So next time we will see the auto transformer and so on. Thank you.